NASA prepares new missions to track the sun and space weather. Welcome back to Techstination. I'm Fred Fishkin. With us from NASA is research astrophysicist Dr. Alex Glocer. Good morning, and thanks for being with us.
Thank you for having me.
Well, tomorrow morning, NASA has three launches planned, including one, the Carruthers Geocorona Observatory, which you work on. Tell us a bit more about what is launching.
Absolutely. So tomorrow morning, we're going to be launching three very exciting missions. The IMAT mission, which is going to look at the boundary between the solar system and interstellar space. The Space Weather Follow-On mission, the SWIFOL-1 mission, which is a NOAA project to do operational space weather um, uh, forecasting. And then there's the Carruthers mission that I'm a part of, which is going to be looking at the exosphere, which is the outermost layer of Earth's atmosphere.
Very interesting. So, give us some insight into the Carruthers mission and its purpose.
Absolutely. So the Carruthers mission is going to be looking at the exosphere, the outermost layer of Earth's atmosphere, and how it responds to input from the sun. It's going to answer some fundamental questions about the size of the exosphere, the structure of the exosphere, and how it's changing over time.
Tell us where the name came from.
So the Carruthers mission is actually named after Dr. George Carruthers. Dr. Carruthers was an outstanding scientist and engineer who is particularly well known for building a telescope that landed on the surface of the moon in 1972 as part of Apollo 16. That telescope actually gave us the very first image of the exosphere, showing that it's possible to image the exosphere and show just how large it really is.
Tell us more about why it's important to understand what's going on with the exosphere.
Yeah, so the exosphere plays a very important role in space weather. So a lot of times you have trapped radiation in nearer space, and that can be a hazard for satellites, spacecraft charging, a radiation hazard. It can induce currents that can flow in power lines down on the Earth. And the exosphere actually plays a role in mitigating the impacts of space weather and modulating that energy input. As that energy builds up in nearer space, it can get relaxed away through charge exchange with the exosphere. And so understanding, the extent of the exosphere and its variability is really important for understanding space weather.
So that if there are events or something, things we can do more or less to prepare for it, or what value can the information be? I guess is what I'm trying to ask.
Yeah, so we want to be able to forecast space weather. In order to take action. So you want to be prepared. If a satellite might encounter anomalies, or if there might be problems with radiation hazard. So these are all things that we want to be able to understand how to predict. And so, for the point of view of the exosphere and how that fits into it, we want to understand how the exosphere is varying and then how that influences the rest of the system.
And this observatory and the other satellites along will be, I'm told, in a special orbit. Tell us about that and the reasons for it.
Of course. So these three satellites are all going to the Lagrange 1 point. That's the also called the L1 point. And that's the location between the sun and the Earth, about 1 million miles away, where the gravitational forces between these two bodies are roughly in balance. And so that's a great location for doing this type of research. For IMAP and SWIFOL-1, this is a great location to observe the solar wind about a half an hour before it reaches the Earth, to give you a little bit of warning and forecasting ability. For Carruthers, this is a great location to observe the exosphere because you're going to be in this location where you can constantly observe and see how it's changing in time and what the variation looks like. but also you're far enough away where you can get the entire exosphere in the picture. The exosphere is really large, and you need to back up in order to see the entire thing. And so this Lagrange 1 point turns out to be an ideal location for making these observations.
Does it make it particularly difficult to put it in place, or you guys really are good at this anyway?
Yeah, we have really great astrodynamics people here at NASA who are able to, put satellites into L1.
Terrific. Does this have anything to do? I mean, we've seen so much activity with the northern lights being visible in different areas where we're not used to being able to see them. Anything to do with that and being able to tell us when we'll be able to see things?
Yeah, so to be able to see the aurora, you really want to be able to predict the response of Earth's magnetosphere. That's the cavity of space of the solar wind that's gets carved out by interaction of the flowing solar wind with the Earth's magnetic field. And some of the observations that we're going to get are going to help make those predictions more accurate.
Where can everyone go to learn more?
Yeah, if you want to learn more about these missions, you can go to nasa.gov/sun, or you can follow on social media at NASA Solar System.
Terrific. Dr. Alex Glocer, thank you so much for spending time with us.
Thank you for having me.